Last week I made a joke about how Triton VM and Stark engines in general are similar to sledgehammers because they turn every problem into a nail. In this video, I will explain why this metaphor is accurate. What are Starks and what are the implications for cryptocurrencies? Snarks and Starks. Snarks and Starks are categories of proof systems whereby a given computation is split into two parts, the prover and the verifier. The prover performs the computation, but additionally produces a proof, which is a short string of cryptographic data. The verifier takes this proof and uses it to determine whether the prover correctly performed the computation. The cryptography guarantees that cheating provers get caught with overwhelming probability. It's like having your mother look over your shoulder while you do your homework, except now it's not just your mother, but every single particle in the universe, making sure you do it correctly. Two properties are key to understanding why Snarks and Starks are popular. First is zero knowledge, which means that the proof does not leak any information about the claim beyond the fact that it is true. For example, you could prove in zero knowledge that you possess 1,000 bitcoins without revealing which addresses they are stored in. Second is succinctness, which means that the verifier's running time is negligible relative to that of the prover, and even negligible relative to that of running the program naively. So what's the difference between Snarks and Starks? Unfortunately, the definitions are constantly being revised and violated in technical terms, but not in spirit. So just as the definitions are fuzzy, so too is the distinction. But by and large, the difference between Snarks and Starks revolves around two features. One, trusted versus transparent setups. Both types of proof systems need public parameters, and the question is, where did those parameters come from? In the case of Snarks, they were generated by a committee who need to be trusted to securely delete their randomness. This randomness is sometimes referred to as cryptographic toxic waste, because if it is not deleted, then this committee can forge valid-looking proofs of falsehoods. In contrast, Starks are transparent, meaning that no trust assumptions are required for the setup or anywhere else, and there is no cryptographic toxic waste. An easy way to remember is that the T in Stark stands for transparent. Model of computation, number 2. Snarks typically work in the circuit model of computation, where wires take arithmetic values and gates combine them using operations supplied by the underlying algebra, such as XOR or addition. As long as you know the entire input, which are incoming wires, you can propagate the wires' values down the circuit to obtain the output, which are the outgoing wires. Starks, on the other hand, typically work in the automaton model of computation, where a relatively simple state is updated across many iterations by a state function whose description never changes. Automaton models include virtual machines and are more conducive to the imperative programming style of C and Rust, whereas the circuit model requires an extra step of indirection. Stark engines and Triton VM. Triton VM is not a Stark, but a Stark engine, by which we mean a virtual machine plus a prover plus a verifier. It's a set of 3 parts. You write the program for the virtual machine, and then you can run it or prove it, and once you have the proof, you can verify it instead of running the program. Implications for cryptocurrencies. So what do Starks mean for cryptocurrencies? There is a philosophical answer and a practical one. From a philosophical point of view, money is the information medium that coordinates the division of labor. And if any one party has a lopsided influence over this channel, they can and inevitably do end up gaming the economy to to benefit themselves at the expense of everyone else. The reason why we do not want to trust anyone with money is because we do not want to give them this lopsided influence. And only with credibly neutral money can we derive a moral good from the voluntary participation of individuals in the economy. Phrased differently, unsound money is morally bad because it tricks individuals into participating in the economy on different terms than those they would otherwise consent to. It is telling that the central banks speak of generating trust instead of eliminating the need for it. So how can we eliminate the need for trust in information systems? Well, that's exactly what cryptography does. Cryptography is the science of protecting information. So it should come as no surprise that cryptography plus currency is a thing. Money was always information, but now it no longer needs a physical carrier. This day and age, cryptography can protect it instead. From a practical perspective, what your computer does when you connect to a cryptocurrency network is verify, verify, verify. You receive a transaction, verify it. You receive a block, verify it. Someone claims to have sent you money, verify it. It would be nice if verification was cheap. And with Starks, it is. Here are a few concrete applications. 1. Transaction aggregation. What happens when you take a bunch of transactions and replace their signatures with a stark proof that their signatures were verified? Well, you can drop the signatures and stuff more transactions into a block. And in case you need to replace the stark proofs with a stark proof showing that the original proofs were valid, you can do that too. So the marginal cost of the witness part of a transaction becomes 0. 2. History verification. When you synchronize to the network, the first thing you do is download all the blocks and verify them, including the transactions confirmed by them. It is a painstakingly slow process that is only going to get worse in the future. But with Starks, you could instead just verify a single proof that establishes that the most recent block is in fact the tip of the longest valid chain. Then you don't need to download historical blocks, much less verify them. The only requirement is that this stark proof exists, meaning that someone has to generate it. And that's why in Neptune, this stark proof generation is baked into the protocol. You cannot mine a block without first proving that its predecessor was valid. The net result is that every block comes with a proof that it is the tip of some valid chain, and comparing two such blocks to see which chain is longer is even cheaper than verifying their proofs. 3. Privacy. With the zero-knowledge feature, you can hide the transaction details, such as the amounts in the case of money, or the state evolution in the case of smart contracts. Moreover, you can hide the origin and destination too. The end result is anonymous transactions without sacrificing the ability of the auditor to verify the integrity of the system and the soundness of the money. This last example of privacy points to a limitation of Starks and of Snarks in general. In order to have sound money, you need a way to prevent people from double spending the same coins. It is tricky to achieve this with privacy because privacy means not leaking sensitive information, such as whether a coin was spent before. Starks and Snarks alone can't do that. So if you want to leverage Snarks and Starks to achieve private transactions, you need to have some other construction on top. That's it for this week's video. Be sure to subscribe for new updates every Monday. If you are interested in how Neptune uses Starks, the best resource is the website, neptune.cash. If you have a question about this video or anything related to Neptune or Triton VM, the forum is the place to go. talk.neptune.cash.